Question number 21. Two numbers having only one as common factor are called dash. And we know that in co-prime numbers, only one is a common factor. So answer is B, co-prime numbers. 22. Which of the following pair is co-prime? And here we need to check which pair has only one as common factor. And we check in this pair, 2 3s are 6 and 2 4s are 8. Your common factor is 2, so it is not co-prime. Let's check for B option, 18 and 35, and we have 3 6 are 18 and 5 7s are 35. Here we do not have any common factors. So here 1 is common factor of both these numbers, right? And therefore we can say that this pair is co-prime numbers pair. Next question is, common factors of 15 and 25 are. So first of all, we write factors of 15 and 25. 15 ones are, 3 5s are. Then after 25 ones are and 5 5s are. We write one time only 5. And here, which are the common factors? So we have 5 is common factor here. Okay, so in the option 1 is not given. See, 1 is also common factor, but it is not given in option. So here we have 5 is a common factor of 15 and 25. So answer is C, 5. Question number 24. If a number is divisible by two co-prime numbers, then it is divisible by their dash. First, you need to understand this question. What is the meaning of this? First, take one number which is divisible by two co-prime numbers. For example, if I take 5 and 7, right? These two are co-prime numbers. And if I take one number that is divisible by 5 and 7 both. So 35 is divisible by 5 and 7 both. 5 7s are and 7 5s are, right? Then it is divisible by their dash. Then this number is also divisible by their dash. Can we divide by its term? 5 plus 7 is equal to 12. So can we divide 35 by 12? No. Then we check the difference. 7 minus 5 is equal to 2. So the difference is 2. Can we divide this 35 by 2? No. Then we check for the product. 7 5s are 35. Can we divide this 35 by 35? Yes, 35 ones are 35, right? So here answer is C, product also. Question number 25. The product of LCM and HCF of two numbers is equal to sum of numbers, difference of numbers, product of numbers, quotient of numbers. And as we have this formula in our textbook, that LCM multiply by HCF is equal to first number 1 multiply by number 2, right? LCM multiply by HCF is equal to number 1 multiply by number 2. So here answer is product of numbers. The product of LCM and HCF is product of numbers. So correct answer is C. Question number 26. We have one factor tree here. The missing number is, we need to find the missing number in this factor tree. Okay, and first we refer this factor tree, and 60 is divided in two parts. 10 6 are 60. Then after 6 is divided into two parts. 3 2s are 6. So here on the place of the question mark 2 will be there. So answer is B 2. Question number 27. What are the prime factors of greatest 4-digit number? And we know that the greatest 4-digit number is 9999, and it is further divided into two parts. 3 multiplied by 3333. We can further divide into two parts. 3 multiplied by 1111. Further, we can divide it into two parts, 11 and 101. Now we check which are the prime factors here. So they are 3 multiplied by 3 multiplied by 11 and multiplied by 101. So here correct option is first, 3 multiplied by 3 multiplied by 11 multiplied by 101. Next question is, which of the following expression has prime factors? And we check every option. In first option, it is given 2 multiplied by 3 multiplied by 4. So we can say that this 4 is a composite number, not prime factor. Then we check this one. All factors are prime factors here. So this expression has prime factors. Then we check further options also. Here it is also prime factors. Okay, so one mistake is there here. It can be in the option that answer is B and C. Okay, then here 9 is composite number, so it is not prime factor. Okay, so answers are B and C. Question number 29. Which of the following numbers has 4 different prime factors? So we know that prime factors are 2, 3, 5 and 7. Now we have taken 4 different prime factors, right? If I multiply these prime factors, then I get the number in the answer. So 2 3s are 6, 6 5s are 30, 37s are 210. So answer is C 210. The product of 3 consecutive numbers is always divisible by dash. And first we take 3 consecutive numbers, then we will check. For example, if I take 2, 3 and 4, 3 consecutive numbers. If I multiply this 3 numbers, then 2 3s are 6, 6 4s are 24. So this 24 is divisible by which number from these options? So it is divisible by 2, 4 and 6 also and 8 also. But we need to check further. Now I take 3, 4 and 5 consecutive numbers. 3 4s are 12, 12 5s are 60. Now we check 60 is divisible by what? Yes, it is divisible by 2, 4, 6 also, but not divisible by 8. So 8 is cancelled. Now we check for 3 consecutive numbers, 1, 2 and 3. 1 2s are 2, 2 3s are 6. Now 6 is divisible by 2 and 6 but not by 4. Okay, so 4 is cancelled here. Then after we check from 4, 5 and 6. 4 5s are 20, 26 are 120. Now we check, can we divide it by 2? Yes, we can divide it by 2. Can we divide it by 6? Yes, we can divide it by 6 also. Now we check for 5, 6 and 7. 5 6 are 30, 37 are 210. Now we check, can we divide it by 2? Yes, we can divide it. Can be divided by 6? Let's check. Yes, we can divide it by 6. Okay, so here we can say that this product is divisible by 2 and 6. Further we check for more options. So now we take 6, 7 and 8 consecutive numbers, and then we check 6 sevens are 42. 42 multiplied by 8, 336. Can we divide it by 2? Yes, we can divide it by 2. Let's check, can we divide by 6 or not? Yes, we can also divide by 6. So we can say that the product of three consecutive number is always divisible by 2 and 6. So answer is 2 and 6. Question number 31. The sum of two consecutive odd number is always divisible by dash. So first we take two consecutive odd number. For example, if I take 1 and 3. So addition of these two consecutive odd numbers 1 and 3 is 4, and this 4 is divisible by what? Yes, it is divisible by 2 and 4 also. Then we check for the next pair 3 and 5. 3 plus 5 is equal to 8, and 8 is also divisible by 2, 4 and 8. And then after, see, this 4 is not divisible by 8, so we cancel this 8 from the options. Okay, then after we check for 5 and 7 for this consecutive two odd numbers. 5 plus 7 is equal to 12, and 12 is divisible by 2 and 4 and 6 also, but this 8 is not divisible by 6, so we skip it. Now we check for 2 and 4 only. Okay, then in next pair we take two consecutive odd numbers 11 and 13. 11 plus 13 is equal to 24. And can we divide this 24 by 2 and 4? Yes, we can divide it by 2 and 4. Then after we check for 15 and 17. Okay, can we divide it? 32. So we can divide it by 2 and 4. Then we check for two odd numbers 7 and 9, and it is 16. We can also divide it by 2 and 4. Then after we check for 13 and 15. 28, and we can divide it by 2 and 4. So here we can say that the sum of two consecutive odd number is always divisible by 2 and 4. Okay, here both options are given. Actually in option it should be given like A and B both. Okay, so here the sum of two consecutive odd number is always divisible by 2 and 4. Question number 32. What is the HCF of 18 and 48? We can find the HCF of 18 and 48 by common factors also, like 6 3s are 18 and 6 8s are 48. Now 6 is common in both. So HCF of 18 and 48 is 6. So answer is C, 6. Question number 33. What is the HCF of two consecutive even numbers? We take two consecutive even numbers 2 and 4, and now we find HCF of both. So here 2 ones are 2 and 2 twos are 4. Which is common factor here? It is 2, right? Then after we check for one more pair of two consecutive even numbers. 2 twos are 4 and 2 threes are 6. 2 is common in both, so HCF of 4 and 6 is 2. So answer is 2. Question number 34. What is the HCF of two consecutive odd numbers? And now we check for two consecutive odd numbers, for example 1 and 3. So what is the HCF of 1 and 3? We know that it is 1 only. Then after we take another example. I take this pair 3 and 5, and now I check what is the HCF of this. It is 1. So we can say that HCF of two consecutive odd numbers is 1. Question number 35. 4 is equal to 2 multiplied by 2. 15 is equal to 3 multiplied by 5. So HCF of 4 and 15 is. Now we check both. Here no one is common factor, right? But if we multiply both by 1, then 1 can be common factor, right? So here answer is B, 1. HCF of 4 and 15 is 1. Question number 36. Find the LCM of 12 and 18. Now how can we find LCM of 12 and 18? So we can find like this. 2 6 are 12 and 2 9s are 18. 2 3s are 6, 9 as it is. 3 1s are 3, 3 3s are 9. Again 3 1s are 3. Now we multiply this prime factors. 2 2s are 4, 4 3s are 12, 12 3s are 36. So LCM of 12 and 18 is 36. Question number 37. LCM of two co-prime numbers is always dash. And now LCM of two co-prime numbers. First we take the LCM of two co-prime numbers, for example 5 and 7. Okay, so 5 ones are and 7 ones are. Now nothing is common, so we need to multiply it, right? So 5 sevens are 35. Okay, so we have taken this LCM 35 as product of 5 and 7. So answer is product of numbers. Question number 38. Find the list number which when divided by 6, 15 and 18 leave remainder 5 in each case. First of all, for the list number, we need to find LCM of these three numbers. Whenever you have given this word list number, then you have to find LCM of all these three numbers. And how can we find the LCM? So we do division process. 2 3s are 6, 15 as it is, 2 9s are 18. Now we can divide by 3, 3 1s are 3, 3 5s are 15, 3 3s are 9. Again we can divide by 3, 5 as it is, 1 as it is. We can divide by 5, 5 1s are 5. Now we multiply this. 2 3s are 6, 6 3s are 18, 18 5s are 90. Now we get 90 here, but in the question it is given that remainder should be 5. Now I can divide this 90 by 6, 15 and 18. So I get remainder 0. But if I want remainder 5, then I should add 5 to this 90. 95. Okay. Now if I divide this 95 by 6, 15 and 18, then I get remainder 5. Okay. So answer is C, 95. Question number 39. Divisibility by 2, 5, 10 can be checked by sum of digits, last digit, last 2 digits, last 3 digits. So here we can say that if I want to check divisibility of 2, then what is the divisibility of 2? Yes, last digit should be even number like 0, 2, 4, 6 or 8. Okay. And what is the divisibility of 5? Last digit should be 0 or 5. And what is divisibility of 10? Last digit should be 0. So in all these three divisibility, we are checking last digit only. Okay, so answer is B, last digit. Question number 40. Which is greatest 3-digit number exactly divisible by 8, 10 and 12? So here we need to find greatest 3-digit number and it should be exactly divisible by 8, 10 and 12. So first we take LCM of 8, 10 and 12. Then after we try to find 3-digit number. It should be greatest. And first we take LCM of 8, 10 and 12. First we divide by 2. 2 4s are 8, 2 5s are 10, 2 6 are 12. Then we divide by 2, 2 2s are 4, 5 as it is, 2 3s are 6, 2 1s are 2, 5 and 3 as it is. Then we divide by 3, 5 as it is. Then we divide by 5. Now we multiply this. 2 2s are 4, 4 2s are 8, 8 3s are 24, 24 5s are. Now we do the multiplication. And it is 120. Now see, 120 is not the 3-digit greatest number, right? So we need to find multiples of 120 to reach to the greatest 3-digit number. And 120 multiplied by 1 is equal to 120. 120 multiplied by 2 is equal to 240. Then 360 multiplied by 4 is equal to 480. Then 5s are 600, 720. So here I get 960. If I multiply by 10, then it will be 1200, but it is of 4 digits, right? So the greatest number having 3 digit which is divisible by all is 960, right? Again I am telling you, first you need to take LCM of all these three numbers. After finding LCM, you have to take multiples of this 120 and you have to reach to the 3-digit greatest number, which is 960 here. Thanks for watching my video. In my next video, we will do practice of chapter number 4. And don't forget to subscribe my channel. Thank you friends. Bye bye.